So thank you so much for coming. We are on the last IDDV360 talk, wrapping up the spring semester. We have our last speaker here with us, Ben Fry. So we're very happy. It's very relevant for the program. I think you all, probably all of you, have been working with processing and other work. So we are very excited. Thanks so much for coming today. So Ben, we are honored to have you here today. This is all yours.
All right, just trying to figure out how to get rid of this. All right. So thanks for coming. This is it's good to be over here. I think it was last year, maybe two years ago, almost to the day. Hope everything's going well with sort of the semester wrapping up ish. So some thesis stuff I'm hearing about. Nervous laughter.
Yes.
So I run a studio over in sort of the other side of Boston, over near Mass General, the Beacon Hill area, basically focused on doing work in information design. We've been at it for 15 years. So we started in 2010. So I've been at it for 15 years. And kind of the premise for it is really about, working with data, but just sort of this, you've got data here and you have people on the other end of that, and what are all the necessary steps to get from that sort of point A to point B. And so we do a lot of, we do all of the back end work, we do all the front end work, we do the writing. The visualization part is kind of that sort of layer on top of all of it that's perhaps most visible, but really just how do you help people work with and understand information. So I'll talk a little bit about that. This is what our crew looks like. We're a small group. This was just after our launch of a product that we did this past fall. Lovely Beacon Hill in the back. So I feel like all the ivy and everything. Lots of brick. And then some of the other folks on Zoom calling in from New York and Hawaii and exotic Arlington, Massachusetts. So often when doing this work, it's really slow. One of the things that we're after is just kind of, given a particular data set, I like to start with kind of what's the simplest, kind of dumbest, most basic thing you can do with it, and just trying to see what's in there. And so a little while ago, the New Yorker, or actually this month, is having their 100-year anniversary. So the New Yorker magazine, about 50 issues a year, and so basically this works out to be about 5,500 issues of the New Yorker. They're known for these really amazing illustrations that they do for the covers. And so just thought it'd be fun to see kind of like what all that looks like. So a couple of years ago, I had thrown this together. Just I was doing work with kind of playing with the New Yorker archive and kind of pulling things from it, and then just wanted to do a quick update of it. So we get a little bit of the some of the fun things here. So they run the same cover every single year. So basically the cover that they first ran, each one of these columns is an individual year, and then later they started getting interesting with like doing different variations of the cover and things like that. As a basic, sort of readout, like just, hey, let's see what all the data looks like. And is there often what we're doing at this stage is there an interesting story here? Is there something else to kind of keep pulling out of it? In this case, so I just mentioned the sort of alignment of the first year, the anniversary issue on each year. We also have some general changes. You can just see a little bit here. We're losing a little bit of the color on this screen, but these shifts, sort of a couple decades, and then you have another couple decades and a couple decades. And roughly, I'm guessing that most of those major shifts are sort of driven by art director input, decisions about changes in media, whether you're using watercolor or pencil or things like that, and also just kind of editorial decisions around what they want the New Yorker to feel like inside of that span of time. Up until we get into kind of the 90s here, this is around when actually producing this stuff gets a lot cheaper. So basically doing full color printing is both cheaper to actually pull it off, but also the production processes are in place. You know, you have the Mac, you're 10, 15 years into desktop publishing. This is an actual thing that sort of we take it for granted now, and you can reproduce kind of pretty much any image you want, any color you want, and you were not limited by these things that were much more of a consideration for the earlier magazines. So kind of chasing the same sort of highly saturated thing that you're dealing with on newsstands. This is what it looks like up close, so we can see this line of covers there. How they change later, so that different illustrators start playing on different aspects of that cover, and then also just this wonderful variety of all of these. But this is just done as a hey, what's in the data, and we'll often kind of kick off a project like this. This is about a page of code. This was about an afternoon or so of kind of doing the updates and pulling the data. There's more work in kind of munging the data and pulling it down than actually kind of building the thing to look at it. Not necessarily something that we're like, right now let's kind of run with it, but just sort of these short sketches wind up being helpful for kind of other projects and kind of getting into other types of work. A more elaborate version of this, a number of years ago, one of the people on our team, Mark Schifferly, one of our developers, was he's very into Miles Davis, was really kind of stuck in this thing about like, we need to do something about Miles Davis. He has this amazing career, and like all these people he's played with, he's this incredible band leader and musician. So circa maybe 2013 or so, 2012, built this interactive piece, just kind of looking at all of these different people that Miles Davis played with, and being able to see just kind of the how he built his band, kinds of the types of people that he included in that. It's fun to do the interactive one, and that sort of put that up online. A couple months later, we were like still kind of like sort of nagging at us still, and so we went and did a print version where we basically said, hey, let's take all of those people, and with print you can get so much more fidelity out of it. And so we did this poster instead. So here's our timeline going around. Miles himself, this is every single session that he did over this period of time, basically these timelines. And then these other lines are individual people that he played with. And so you can see these different clusters that pop up. So here he's in the sort of big band era. This was some of his earliest stuff, kind of a set of people that he was kind of swamping around a little bit. Had some drug trouble kind of like later in career, and kind of had and then this sort of revival and kind of coming back to it. Also doing some things like here, we're just kind of pulling out, for anybody who is not familiar with his work, I am not a connoisseur of Miles Davis or his over, and instead, how do you have a little bit of a, but I've heard of Kind of Blue, or I've heard of, particular albums, and so being able to see where those are identified to be able to get a sense of what's in those. So up close looks something like this. But this is, it's nice to kind of work in these different formats, get a little bit more with print. We can get a ton of fidelity out of it, right? So we don't have the advantage of doing interactive things, but this is also a lot more fun because you can put this poster up and you can have it up in your wall, and people who aren't inclined to kind of go and sit at the computer and look at data viz stuff can actually enjoy this. And also that print has this advantage too of it can kind of sit on the wall, or it's kind of something that other people can come and, it's a much more accessible kind of thing. Also as graphic designer, with lots of graphic designers in the office, it's really fun to do print, go to the, do the on-site press stuff. Basically the press people, they had to hit the gold twice in order to get this to work. And so just incredibly complicated to have these massive presses, and they need to be able to have it, print out these posters. So just fun to get back into doing print a little bit. A much more recent version of this. So based on that work with Miles Davis, one of the people in his earliest band was Ron Carter, who's a jazz bassist, and he has the Guinness Book of World Records citation for being the most recorded jazz bassist. So he's been on something like 1,000 or 2,000, depending on how you count, different recordings, albums, etc. Kind of a phenomenal career. You know, like if you you have probably heard something by him, even if you are not into jazz, and so we had kind of the opposite problem of with Miles Davis. It's not about Miles Davis and who, you know, here are all the people he's brought into it. Instead, it's here's Ron Carter kind of orbiting around everybody else. You know, like he's always there, just playing away and doing his thing. And so how do you create something for that? You know, so this was a really tricky as far as how to do something that, you know, allowed people to just sort of explore the things that he did. So we made the focus about just really quickly be able to kind of move through it. Made it about mobile as the primary thing to most likely to have sound on. So basically be able to listen to the different tracks. Unfortunately, the audio is not coming through at the moment. But how do we just having a way to kind of, you know, explore through this and then see all these other connections, you know? So one of the, you know, and again, you've probably heard something that he's on. You know, we kind of went around people around the office were kind of figuring this out, you know, bit by bit, as far as like, so we had somebody who was watching Twin Peaks at the time, and so she's like, oh my God, he was on the Twin Peaks soundtrack, you know, and then somebody else is like, oh my God, he was on the Tribe Called Quest album, you know, like the biggest Tribe Called Quest album from, you know, the 90s. And then you have Mark, who did the original, you know, Miles piece, and he's like, it's on everything, you know. So you know, just a interesting story to tell and sort of fun to get into that. He is also like, we just got word his 88th birthday is coming up in a couple weeks. So we're hoping it's kind of time to come back and do a poster version of it or something. Like there's something else to do there that I hope we have a chance to get into. And then pandemics. So, you know, switching gears a little bit. So that so we'll do projects like that. We like to jump around between different kinds of domains as much as possible. This is part of what makes it interesting. So, you know, for me, one of the realizations I had while studying design as an undergrad was, you know, that this moment in studio in freshman year, like realizing that I could take any random thing I was curious about and like turn that into work. Because it's like, oh, I'll do a design project about this thing. And it gives me this, you know, avenue to like kind of dig into and start learning about this. And so in the case of, you know, so, and then kind of taking that through the work. So things like the Ron Carter piece, it's like, oh, this is this amazing thing to learn about this bassist. You know, or up through things like our pandemic work we've been doing. So Party Sabetti, she's this incredible researcher who I've known for many years, works over at the Broad Institute. We were postdocs together back when I was a postdoc there as well. And basically has been, you know, working on infectious disease and, you know, SARS and MERS and Ebola, and basically doing this push around, you know, hey, we're going to have a pandemic. This is a thing. And we spent a good 10, 15 years on proposals with her about like, hey, we need to build platforms for how do we respond to a pandemic. Here she, you know, she was even one of the Time People of the Year in 2014 or 15, just after the West Africa Ebola outbreak. And that was still not enough to kind of like get funding for this thing. And then basically coming into 2019, they, you know, they're kind of closing in on funding for this project finally. And so it's like, great, we're going to get, you know, the right amount of funding, and we're going to have this very considered, you know, 5-year, like, let's build the right platform, whatever. You know, the funding comes through in January 2020, and guess what happens? You were there. You don't have to guess. So basically, you know, in the months that followed, then it kind of went from, okay, so we have this like really considered, you know, we need to put 5 years into this and really, you know, kind of build a resilient system to, okay, we have to do that, but also what can we do this week? You know, like what's something we can actually deploy and get, you know, how do we respond to the current moment, use what we've learned from that to actually build better tools. but also do that in a way that doesn't, sort of undermine sort of the long-term work that we're trying to do here. So in the U.S., COVID was a big deal, but the other half of this project is Dr. Christian Happy, who is based in Nigeria, and for them, it's they're more worried about Lassa fever and Ebola, malaria. Malaria is an ongoing thing. HIV is a huge thing, and so they, so COVID was just kind of one other thing kind of in the mix, and so we can't over focus on that because half the team is has larger issues that they are dealing with, and we need to build systems for them as well. Stateside, we did some work with. This was with Colorado Mesa University, so basically a 10,000 student university in a sort of somewhat rural part of Colorado, Horn Bovers. If you follow U.S. politics, her district, so you can get a sense of kind of who's there and who's voting. And basically, they wanted to. They were interested in how do we address this. Because they like closing the school down is not an option for them. It's how do we, these of this student body are first time people. This is they're the first in their family going to college or university, and they felt if we have an off year, if we're shut down, whatever, we're going to lose a lot of those people. And so how do you make sure that you're on board and addressing that and sort of, kind of working with that community to keep people safe. So this was a good environment for us to kind of be able to work with them on the ground. We got approval for it kind of just after we did a sort of sprint over the 4th of July holiday. Just after that, we weren't going on holiday during lockdown anyway, so that worked. And then basically had to deploy something in August. So like just before as school was getting started, and basically just as they were doing school, just kept adding different layers to the system. And so we did, built a whole, mobile check-in app thing. And, this is the, the front page. This is kind of the, 10,000 foot view for the administrators to just kind of say, yeah, cases are going up and down, and how many people have campus clearance through the mobile app, and how many tests are completed, the testing sites, how are they doing, just kind of what the administration needs to know. And then down here, we start getting into the more interesting stuff as far as, it's not just a matter of, hey, here's this random collection of 10,000 people. It's, what are groups and, subgroups and communities that we can identify that we want to do a better job of tracking, or who's higher risk, where might things spread, things like that. They also did their own wastewater testing. So this was kind of, one of the things that our collaborator parties really pushed on with them is, instead of this being like, oh, woe unto us, we're dealing with COVID. This is, what can we even do this year? Instead, kind of turning this into like, what a cool opportunity to, what are opportunities that we can kind of build out of this? And so the mechanical engineering department and the bio department got together, and they figured out how to basically build their own wastewater testing system. As the Becky folks went and kind of did the hardware, the bio folks did all the testing and the from the genetics and analysis part through the wet lab work, actually it's the other way around, and being able to test this. So these are the different sites on campus where they were taking wastewater data. Wastewater is helpful to kind of see like, hey, are we have we caught the different cases? Are we isolating the right folks? How do we keep folks safe? Gets more interesting when you start doing things like this, where you basically have different cluster, groups of people. Here are, test results for folks who are positive. This has all been de-identified, and the team names have changed, so it's not actually the basketball team in this particular operation. But being able to take that data for, here's a bunch of people who have tested positive, and let's build out this phylogenetic tree, which tells us things like, so here's all the, without getting too far into the biology of it, basically how related are these different samples? So we can get some sense of, these are all highly related because they have very short branch links. They're all kind of occurring at a very similar time. And then things here are outliers. And so what they're looking at here is, who's giving it to whom, and or it's sort of an approximation of that. And also how much of this outbreak is started by on campus and being passed to the broader community in the county or in Colorado, and how much of it is being brought in. And so pretty cool to be able to just kind of do this sort of thing live. And like usually this is stuff that you do months later in a paper, something like that. And then also just down to dorm level. Here's the 4 stories of a particular dorm. Poor Emma Thomas is positive, and we know who that person's roommates are. Who else is in that hall? We see, oh, there's women's lacrosse and women's soccer in that general area. This is a potential area. We are a under-resourced school. We can't just it's not what MIT or Harvard, who could just kind of test everybody. I don't recall what the Northeastern set was, but like basically, how do you know who to test, and how do you make good use of limited resources? We got a nice write-up out of it. This is the students from bio and mechanical engineering sort of making their way around campus with their cart that they put together for wastewater testing. But really, so since 2020, this has been just a ton of we're just trying different angles, different slices of the problem. That it's everything from this sort of more dashboardy, like, hey, what's the situation on the ground, through to tools for researchers, and also a lot of these are tools that researchers haven't necessarily worked with before. We're dealing with different data sets. This is a thing we built around. So mCarmen is another thing that Pardee's lab is working on. That it's a way of basically doing testing, and for like $1 or 25 cents, you can test for 20 different diseases all at once. And so very cheap testing. So that's pretty cool if you don't have to go and, hey, we're going to give you a COVID test. Oh, that's negative. Okay, let's give you an RSV test. That's negative. So we'll do the flu A, flu B test. Instead, we can just kind of do all of that at once. What do you, how do you start sifting through all of that data? Also some things on outbreak tracking across very different densities of population and so forth. And so just trying to go as quickly as we can through different variations of this work. And this sort of sketching and prototyping loop is really, really important for us. So not unlike that New Yorker piece I showed you at the beginning. It's like, oh, whatever, it's New Yorker covers, but same kinds of things apply as we're dealing with more serious things, different kinds of data sets, and just getting flexible and quick with working on those data sets. So sketching, prototyping, a good bit still just in sketchbooks, just kind of drawing things out and kind of thinking through that. Other times, so this was one of the first things we made was, spring of 2020, there was just kind of an overload of the amount of text or the amount of printed materials folks were using. And so like the caseworkers all kind of trying to do contact tracing manually, not a great way of working. And so we kind of took that and put it into a mobile app that was going to be nice and straightforward, take people through it quickly. Over on the design side of things, for those of you doing heavier information design work, the population density is a huge problem whenever you show a map and you show a ProPleth map, and it's like, oh, there's a lot of cases in California, and guess what, New York too, and oh yeah, you know what, that's where all the people are. And so instead, how do you kind of take that into account and like design for that? And one of the things we did was, let's take a population density map and use that as our background instead of just kind of filling in states. And then we can see things like what cases look like. And, oh, it's actually, here's what's happening as things, as cases move up and down the 95 corridor. I apologize, it's a little bit dark. In real life, it looks like this. So basically being able to, and here we're also looking at things like variants, like where are the different variants moving, and be able to work from that a little bit. We spent a lot of time looking at, newspapers with their charts for like cases are going up and cases are going down, and they're maybe getting a little better. What's it mean that it's higher? as we know from living in this area, we've got the best we usually would get was Middlesex County and Suffolk County, and those are very diverse, very large populations, a very different range of people across each of those counties who have extremely very different risk profiles and kind of what their exposure is. I live in Charlestown, and just across the bridge we have Chelsea and Everett, and basically in Chelsea something like 50 or 60% of people were deemed essential workers, because they were like working in food service and other sort of support things. And so that's very different from a bunch of affluent folks in Cambridge right nearby, or certain parts of Charlestown who can just safely kind of sit at home and do Zoom calls and things like that. And so this was our work, some work that we did around how do you make an app that kind of does more specific neighborhood focused looks into that data to try and take more of that into account. So here it is still in the sketch stage. And then on the tools for researchers front, one of the things that less so now, but for a stretch, one of the most important things for the COVID work, the SARS-CoV-2 COVID work, was looking at different variants. So you'd have, the people love to talk about the variants in the news, and the different naming styles that we worked through and all that. And so basically, when you have a new variant, when that shows up, it's like, yeah, I know a lot about, Delta, or I know a lot about Omicron. Another variant comes along. Well, how are they similar and different? And, across those, you'll have different mutations. So here we're showing each row is a particular variant. Each one of these blocks is a mutation. And then, we can get a general sense of, okay, where are the mutations similar and different? And so basically you have a block where the mutations actually align with each other. And but not all mutations are created equal. And so instead of just kind of treating it as like, well, this thing changed and this thing changed, we're coloring everything based on essentially what's known as the fitness score. And basically, hey, this mutation is actually something scary, or like that's something that's really propagating itself in a much more aggressive way. And so we're looking at shared versus divergent. And then we can also add another layer of color to that to say, and actually these are the scary ones. So the blue one, this dark blue, indicates the speed. So the intensity of these colors are how quickly that particular mutation is taking over. As it moves into these warmer colors, that is how much we should actually care. Like, is it this particular mutation, is it making it more virulent? Is it making it symptoms are worse? Things like that. Again, this is here's what the colors look like. Pop out a little bit more, and so a nice use of color as a way to kind of be able to show multiple aspects of the data at once, but hopefully show some variation in there too. A big focus around what we're doing in the scientific work is really about how do you move these processes further upstream. So instead of there's a tendency within visualization, the way that folks think about visualization within science, that it's like, well, I'm going to sort of do all the real work, and then at the end maybe I'll get somebody to like make a nicer figure for me, or kind of clean that up. And not a particularly useful way of approaching the work that you all are familiar with. And instead, what we want to do, so this is an example of a paper. This was about Mpox, the outbreak. And so there's an outbreak that happened a few months prior. Wrote a paper, put it all together. Let's have some figures. Let's sort of map these things out. Much more interesting if we can do that live while the outbreak is actually happening. So like let's track this before people are dying from it, and have a better sense of how to do that. And so this is one of those platforms. This is using the same data. We can run this over time, very quickly get a sense of different aspects of what's happening in the outbreak. This is we're looking at Nigeria here, different states of within Nigeria and how heavily affected they are, and the our now ubiquitous tree over at the side to kind of tell us something about breakdown of cases. We also have the light mode version, so we do like country and Western. It's like both kinds. More recently, we've been taking versions of this to do a more generalized way of kind of building these platforms. So you have public health departments that are under-resourced. You have even more so now, folks at the federal level. So this is work we've been doing with both our collaborators in West Africa, but also we just turned in a version of this with the CDC plus the Massachusetts Department of Public Health yesterday around tracking salmonella, for instance. Here's a version we built around, so this is a variant. Here's the US version with simulated data. So how do we just very quickly get through all of this data? We do some interesting pre-processing stuff so that we don't need an extra server-based infrastructure on the back end. So we want to have things really fast, really low resource, et cetera. And so here, just being able to query through that stuff nice and quickly. Another version, this is simulated data, because I can't share with you the real data for the folks in West Africa that we're working with. But the kind of, the different pieces of this that they're looking at, and, sort of individual disease views. And then another version of that MPOX stuff that I showed, sort of in and running in this platform. So we wanted to have a nice flexible platform that we can kind of within a half a day, 2 days, go from having a data set to having views of it and being able to filter across it, and then put this in front of people who can actually make decisions based on it or do research and things like that. So quick deployment and low resource and et cetera.
Can I ask you something? What kind of experts use these tools?
So
what is their goal and background?
Yeah, so that so it depends. So in this case, this is going to be people doing response. So there's so much more. Generally speaking, this is a much more technical audience. They are so I think about this the main view with the multiple cases. That is a higher level public health official at the state or country level for Nigeria. As soon as you've gone into a particular disease, that tends to be more of researchers and people who are doing response for that particular pathogen, generally leaning much more toward the technical side. That in contrast to say that what the Colorado Mesa version that I showed, that front page was for the vice president of the university and the head of public health on campus, but that needed to be something that was just really straightforward. Also, the person deputized to run response on campus was the assistant football coach. So you've got the VP of the university, the assistant football coach, and the head of the public health department, which was as in teaching public health, not necessarily running the public health on campus. Those are the three people that that one needed to work for.
Would you say they do monitoring with it as well?
So yeah, so monitoring and so in their case, yeah. So it's they had to answer questions like heading into the Thanksgiving break, they were making a decision around, okay, Thanksgiving's coming up. Do we have everyone go home and then come back and bring like have a nice little mixture of the different variants that folks are bringing back from home? Or do we want to just send everyone home? Let's do that. And in fact, they had this, spike in cases around Halloween and so forth. And so made the decision to. Yeah. So then over on the researcher, tools for researcher side, a big part of what we're doing, so again, sort of the tendency to think about visualization is this sort of, hey, I have some data and here's a picture of it and I want to, understand what's there. I think more interesting to think about it from the perspective of how do you use this as a way of working with data and using that process of working with the data as a way to understand it better. So one of the things we've been working on that just got to preprint this week, which is exciting, this tool called Delphi, which I apologize. This should be running nice and speedy. But basically, what we're able to do here is these phylogenetic trees that you've seen in some of the other examples. Basically, this is what you do to understand what's happening with an outbreak or how a pathogen is changing over time. And what we can do here is, so we have this really brilliant guy, Patrick Verley, who's working with Pardee's lab, who built an engine to allow this to build. So for people, it's basically doing Bayesian phylogenetics in the browser. And so the system that he has created allows you to do it about 1,000 times faster than the other existing tools. 1,000 times faster than the leading brand. And with that speed, so it's nice to do things faster and whatever. But where it gets exciting for us is that speed now means we can do things like run it directly in a web browser. So instead of so typically running this particular tree takes about 5 or 6 hours. You upload it somewhere to the cloud. You run a command line process. It spits out text at you, and you get this sort of console log kind of stuff. And then you kind of say like, I think it's run along, like I think it's done. Hit Control C and stop it, and then kind of check the results, and hopefully you have the results you want. I'm not exaggerating. And basically, with this, so because we can do that same work in about 5, 6, 7 minutes, and even within a couple minutes get an approximation of it. It is so not only is it nice because we can kind of do this work faster, but it gets scientists to their next step faster, right? So I want to very quickly get a sense of, is my data actually garbage? So you can go through and see the tree starting to form, and there's a couple of these weird outliers. I'm going to drop those back out because that's actually bad data. Rerun your tree. That is not stuff you have the instead of kind of running it for 6 hours and sort of doing the punch card version of the process. Also interesting for us is now that you have all that data, what can you do with it? And in particular, one of the problems with trees is that basically they're lies. So it's kind of here's our best guess at what this data actually means, or here's our best guess at how these different things relate to each other. When in fact this is one tree out of a few million possibilities. We have calculated those many million possibilities, and we're showing you the best variant that's been found so far, based on some scoring metrics. And so a big part of what we want to do is kind of reinforce this idea of uncertainty. People like to talk about uncertainty and visualization, and very few people are doing let's do something about it. So here, for any of these mutations that show up, I get the zone of where they may have actually shown up, and I can see that a bit more clearly. I can look at mutation prevalence over time. I can select different parts of the tree and see how they're related to each other. And so very quickly, as a researcher, this is me being able to kind of poke at the tree and kind of pull it apart. Because the other part about, or the other aspect of these trees is it's not the shape of that tree isn't what's important. It's what the tree says, right? It's what the tree actually means. So how do you get people as quickly as possible into the actual meaning part of that? I think about this. So back in undergrad, I did a bunch of work in child psychology as I was thinking about sort of doing interfaces and things like that, and was always struck by the ideas around constructivism and this idea of you can't just kind of shovel information at people, and instead, how do you the best way to actually have people learn is that let them kind of play with it and kind of look at it and take things apart and break things and build things. And I think it's a really useful way of thinking about tools and information design. That basically, how do you, instead of kind of you're not just kind of creating things to for people to sit there and passively take in your graphic or whatever. Instead, it's you're trying to give them this experience with the data so that they can sort of use that as a way of generating a mental model about what the data actually means. And so taking that into the tool I was just showing, it's again, it's not the picture of the tree, it's not the specific structure of the tree, it's them being able to generate this sort of mental model of what what does the outbreak actually look like based on what I was able to learn from this tree, and sort of be able to kind of poke at it in different ways, and see which parts have ambiguity and which parts do not, and so on. Cool. And then I think it's my last thing. I'll just we've been working on a tool called Rowboat. So having been at this for a while, we keep wanting to take some of the things that we've learned from working with clients and try and turn that into a tool that we can use for ourselves as far as trying to make sense of data sets, and B, hopefully that's something that we can get other people up and running with. That there's a lot of stuff for which you don't really need a visualization. You just kind of need to understand what's in your data and how do you get folks into that. As many of you are aware, data sets often show up kind of looking like this. We have these massive Excel files. So this is maybe 65,000 or so sequences. These are the first 65,000 SARS-CoV-2 sequences that for the first couple of months of the pandemic. The metadata about them, we have the location they came from and the submission date and the host and so forth. Excel's often used, but often not a great way of looking at this. So we built this tool called Rowboat, like the Delphi tool that I just showed. Before we get to this, this also runs entirely in the browser. So there's no uploading, so no cloud, no sharing your data, whatever. We can just do amazing things just directly in the web browser nowadays. And so basically, how do you take a data set, drop in the browser, and very quickly get a picture of it? So here I've got that 65,000 row file. I was able to load it in about 1/10 of a second. So it's also faster than Excel, even as a sort of expensive product in your desktop. And we've instantly been able to, it ascertains things like, oh, this is a date column. So let's see a distribution of all of the dates. So I've got some weird outliers happening here. Location. So this is a couple of unique locations. This goes on. Okay, we've got about 2,300 or so different unique locations, and get a, most of them are Europe, United Kingdom, England. Let's see, sequence length. We have lots of different variants, and then a big spike in the middle there. And so, so these are things that are just kind of happening automatically. I didn't have to do any work in a Python notebook. So typically we're going to do Python notebooks or Tableau or Power BI or whatever your tool of choice is. And it's kind of like things like how do you build something that's hopefully simpler, like faster to get you up and running with those, and then also kind of integrates with your process in different ways. You can talk about that in some of them. But in this case, what are these outliers? I can just select those. Hey, it turns out, those are different hosts, so those aren't actually human sequences. Those are a couple of bat sequences that are part of this, kind of based on SARS-CoV-2-like diseases that were in there. Having filtered down to that, I now have a graph of COVID over time for the first couple months, just automatically. So I haven't kind of sat down and created a whole chart or fired up D3 or observable or whatever. I just want that picture. Sequence length, similar issue. As you do DNA sequencing, the results you get back may or may not have the full sequence of the virus that you put in. And so, there's different bounds on how much you actually want, but how to quickly kind of zoom in on just the ones that are long enough to make sense. We can also get the breakdown, sort of geographic breakdown of where these are coming from, collection dates, and so forth. Linking two different columns. So we've got collection date and submission date. And once we've done that, we can see things like, so here's when the sequence actually went into the database, when it was actually collected. And so what you get is these specific, sort of people playing catch up and filling in the database with much older samples from months prior. And so we can very quickly see those kinds of trends. So here we're going through and just kind of very quickly getting a sense of how much garbage is in our data, what might be interesting, what's useful. How do you make sense of the data set before you commit to visualizing it, or before you commit to building something with it? And so now maybe you go to Tableau or Power BI or D3 or whatever, but do that after you've have a better sense of kind of what you're going to look at. Also things like you have a latitude and longitude column. Let's just see that on a map, and so we have a globe map. So you've got those, and then we can also do things like if there's also a time column associated with it, we can see just play that back over time. And so this is 20,000 rows of shipping data, and so just by plotting out all those lat long points, we can get a sense of, great, here's all these different shipping lanes, and here's the what's busy and so forth. And then we can just play it back over time to get a sense of where and how these ships are moving around. So we're interested in sort of the very early part of the process, and and then once you have a sense of what you're dealing with, how do you do something like it? Do we need something much more high end and a tool that's really going to get you into this, or do you need something that's more off the shelf? Yeah, I just want to do I just want to show this map and play this back over time. That's a fairly constrained, straightforward sort of problem, but just want to make that nice and efficient. So that's online. So robo.xyz, sort of free to use most of or all of the features that I just shown, and so we're just trying to figure out what we want to do with that and kind of building. We did a big push to get it done, and now we've had to move back to our client things. We're kind of going back and forth. Lots of things we want to do with it and haven't yet. But yeah, I'll close there and.
I do have a question. How do you know when to follow visual conventions for the visualizations that you're working on, and when to innovate?
The biggest part is the audience, and so so for the vast majority, so the audience and also just the setting in which it's being done. Decent example is. Even this. So this for our audience of researchers, easily half, maybe 3/4 of them. This feels like sci-fi movie stuff, black background, And the first time they actually saw this version of it, there were actually cheers in the back of the room. They're like, "Oh yeah, this is real data." This is a pretty mundane, got a map and some bar charts, and this is pretty basic stuff. And so that's kind of the thinking that's going into the visual choices for what we're doing here, what's included. It's pretty basic. We're doing charts, things go up and down, and so that visual language is even kind of taking another step or two back from that. By comparison, you have stuff like here, where part of what we want to do with this was get people interested in what we can do. So instead of it just being like, hey, here's the minimum we're going to do to kind of get things over the finish line. Let's get people excited about what these platforms should work like. And sometimes it's helpful to kind of have something that feels more like the movie version, and especially if it's real, that it's like, yeah, we actually have the dorm layouts, and that there's a whole privacy thing about that as well, but just the this is extremely doable kind of stuff, and so we want to kind of push that with folks. There's also so there's so kind of depending on the audiences, we have another version of say for this middle one that I was showing, just this week we're looking at do we need to kind of have a more interesting version of this? for a particular funding thing around like, hey, this is the most interesting, advanced, whatever sort of system, because, you know, this visual language, this doesn't say this is the most advanced, you know, whatever. And so, you know, doing something that, even if it's not necessarily the thing that ships, or it's not, you know, for the audience of people who are deciding about what the future should look like, versus the people who are using it day to day, what are different, you know, when is it appropriate to kind of use different voice and different ways of looking at it? Is that more or less answer?
Yes, thank you.
I think I have a somewhat connected question, but more on the technology side.
Yeah.
I really like that most of you, basically all of your projects are bespoke kind of data interactive visualization tools. And I personally think there's always value in doing that.
Yeah.
But I'm curious to hear from your perspective as a company,
yeah.
How do you balance some of these things could be done with the off-the-shelf?
No, sure.
Right?
Yep.
And I guess that from the perspective of a company, you can save on time
Yep.
and effort, you would do that.
Yes.
So I'm just curious to hear what you think about bespoke versus off-the-shelf, and maybe in the future, these things are going to integrate somehow.
Yeah, no, I hope, right? No, it's a great question, and again, to the purpose of the talk, I think it's a big part of, if not we as a group, but I'm in charge of thinking about as far as how, like, which things need to be bespoke and which things need to be, you know, even the, you know, like this. We all know how to plot latitude, longitude coordinates and do point to polygon testing and whatever, but also it's like D3 map. We can just put, you know, D3 geo in there and it's fine. I think there's a couple different ways of, you know, a couple of different threads for that. One is often our clients are coming to us when bespoke things have broken down, you know, so a decade ago, they were sold like, hey, do a dashboard. What you need is a dashboard, you know, and it's like, dashboards. Everyone's getting their data going, like hired a couple data scientists and they're doing dashboards. And so now they're like, hey, so we did put all that money into a dashboard and we just now understand what we want to know from this. Or that data is actually, we have 1,000x or 10,000x the data that we had designed it for. Or, but most commonly, it's kind of, we have a different, you know, the dashboard was just enough to kind of get us a picture of what's even here. It's essentially you know, for me, it's the New Yorker piece, right? It's just, here's what all the data looks like, and people kind of stop there. And so we're often kind of being brought in to say, okay, here are the different threads that you're actually trying to understand from it. And with that, that often requires something that's a little bit more bespoke. Especially as we're dealing, you know, if we're rendering this tree back in that other Delphi tool, one of the things we want to be able to do is on that. Let's do some genetics, folks. Okay, so we're running this tree. Let's see the updates first. But here, this is, you know, this is much more bespoke because we want to do performance things like just be able to very quickly get through. Oh, it's not showing quickly though. Yeah, so like just here's all the different trees, and this is, you know, kind of, that's our visualization of like every tree is alive, you know, because we're picking one of these that is at the best so far, and we're showing that in the middle. But that is a useful thing to kind of, you know, convey for folks. So sometimes we're doing that for performance. Sometimes we're doing it because it's a particular view that doesn't really exist. You know, so I'm choosing different points in the tree, and I would need to be able to very quickly see kind of what these breakdowns look like. Most recent common ancestor, comparing those, updating these. These I think these are just done by hand, but we'll, sometimes drop in some basic components. And then, sort of over on, you mentioned kind of the business side of it. Part of the business part of it is, so I have these awesome people who I work with who are really good at building that bespoke stuff. And so every once in a while, I have to be the one that says like, hey, we don't need to innovate on the login page. Like it's like a username and a password. Like it doesn't need to, and in part that it's not even a matter of like wanting to innovate on that, but just sort of the how do we make sure we have useful base components for the for the places where it's appropriate to have base components, or in the case of building things for different audiences, like I mentioned, just kind of visually what the researchers might be like, it's a little too sci-fi. If they're kind of conditioned on tools that look a certain way or look like all the other tools, sometimes we need to kind of go in that direction a little bit so that they're more apt to trust it and more, like if we're doing something that's a little too bespoke, it's not that useful. So I used to say it's something we spend a lot of time, or I spend a lot of time working on with folks.
I love how you guys, the studio embraces complexity. Like, for example, having the researcher being able to explore the different versions of a tree and, how likely or unlikely they are from what I'm getting.
Exactly.
So when you go back to your audience and show them these interfaces, do you find difficult for them to match their own understanding to the visual forms that you're choosing, and how you navigate that?
So let's see. Yes, so yes and no. So the yes part is, so the no part is hopefully along the way we have done enough. We spend a lot of time talking to them, or not hopefully, we have spent a lot of time talking to them. All of these representations that are on screen come from about 20 or 25 different variants of sketch prototype live data prototypes that we did, that we assembled, took that to put those in front of the researchers. We said, hey, we can do this with the data. Is this useful? Is it interesting? Is it intuitive? And basically this, what you see here is the result of all of that. The maybe it's not doing as well. Part of it is this is done under deadline. And so we have all the different pieces. This is still, from information design, with my information design professor hat on, it's the hierarchy here is not working, and that there's, and especially as far as how people learn this as a new tool, we need to do better things with, just kind of how some of the different components are put together. Really shouldn't do this, but I'll open up Slack because this is, so now Paul is actually working. Yeah, so one of the things we're looking at now is, now that we've got this out, we didn't see anything we weren't supposed to see there. So now let's think about actually cleaning this up, so front page, do we actually need that second tree? So it's sort of a flex to show the, the trees and all that, but we can probably do that with one. And also that these other charts, we've had to, grow the number of these sort of side charts from 3 to 6 during the process. So those actually are much more important. We also have this readout that right now is kind of, so this, we had to tuck this in. We're kind of jamming all these charts in because, 2 were added late in the process. This is now really important. Basically this is saying, when can I hit the pause button? And so our most useful parts here, we need to rearrange things based on that. And to the thing of kind of what's, how do folks respond and, what's overwhelming, we want to make sure that the right elements are coming forward. And so this is one step towards some of that. And then here, this is what the next page, we want that to look like. So instead of getting everything into one sort of view like this, can we start kind of bringing apart different you know, like how much detail do we need around these different, just telling you how great this tool was, and now I'm showing you the critique on it. So, no, it's great. You know, so for all of these, there's a lot of information, and we've given a lot of space to all the those different variants. In fact, screen, there we go. In fact, this is important to understand this overall trend. And, you know, can we put those variants down here where I can actually see more of them and group them in different categories instead of having sort of scrolling lists inside of scrolling lists. And then this is Paul putting something in the last page to make sure we've actually looked at the PDF rather than just being like, oh yeah, nice. So keeps it interesting for us. Yeah, so like, you know, so this is one of the, so now that we ourselves have a sense of, you know, the actual problem, we've had more time to work on, have other researchers using it. We've seen what they get confused about. And so we can start doing some more to kind of bring forward different elements that will help them learn the tool, but also help them focus on the, you know, the most useful aspects of the tool. Because right now, as much as I'm pleased with it, there's too much, you know, there are too many things that people need to learn as they're, again, at the risk of growing my tool.
I'm curious about that because similar to what Tina was asking, so here we have in the crowd different students from different levels of the program. So you have been doing this for a long time. So what would you say to the students who are just starting, that when you say a data set of, I don't know, how much, 20,000 rows or whatever, I even say, oh, Jesus, that's a lot of data. How could they start working with something like that? So it doesn't feel so intimidating to work with such large data set.
Yeah, I mean,
for instance, the students are trying, what do I ask to the data?
Yeah.
Well, how do I know what to look for?
Yep.
That kind of thing.
No, so two things. One is, this is why, you know, part of the reason I had that New Yorker covers thing in the front, because, you know, it is very useful to just kind of say, what's the data look like? You know, and that I often like doing that with print. You know, like just what can you do? We did some stuff with Mayo Clinic on electronic medical records, and that, you know, one of the first things we did was just every aspect of somebody, you know, a patient's medical history over, you know, over time. Let's just print all that out and put it up on the wall and see what that looks like. Is that an important, you know, is that a concrete, important, super insightful visualization? Not necessarily. But it does give us that first pass of, oh, weird, there's this like clumpiness that happens here. And there's, you know, if you think about health events, that is the, you know, the nature of health events is nothing, you know, like lots of stuff, and then not, you know, not much anything else. And oh, so now that's something I need to make that's going to be core to whatever design you make. So, oh, I might have a timeline, but it's about how do I navigate between these events, not just, oh, here's, you know, all time is equal. And so, so literally starting with, you know, people kind of cringe when I say it's like the dumbest thing, but it's like, start with the, you know, just something that's very straightforward. And also in the case of that one, our partners at Mayo Clinic were like super excited about that, because usually they're accessing that data through this really awful electronic medical record software called Epic. And judging from the groans, maybe a couple of people who've dealt with that. And so instead, and there's no way to just even see that view. And so they're, you know, so like that wound up being a whole separate part of the project. They're like, hey, can you actually work in the timeline thing as a critical, like just how do I learn as much as possible about a patient if that's really valuable for a doctor? In the case of when I started doing, you know, for my graduate work, I was learning about genetics for the first time since, you know, like high school, and would basically be sitting in class and that, you know, the professor's saying things like, yeah, you know, the human genome, the, you know, the shortest is the, you know, chromosome 22, and it has about 50 million letters, and the longest has 250 million letters, and that's chromosome 1. And, you know, so I'm saying, oh, wow, what's that look like? And maybe I could just put that on a poster, but that'd be cool. I get 50 million letters and, you know, kind of do that. And it doesn't quite turn on a poster. It turns out, 50 million is like a lot of stuff. Yeah, so here's like 1/4 of,
Oh my God.
so that's 1/4 of chromosome 21. So about 12.5 million letters. Done it with this 3-pixel font and kind of coloring things based on what's real, sorry, not real or not, what's coding versus non-coding data, and basically 37.5 letters per inch. So if you really kind of look at this very closely, you can actually see what this looks like. So this is an 8 by 8 foot version of it. This is from an older show, but this was a chromosome 18, which is about 75 million letters, just filling an entire wall about 18 feet high and 21 feet wide for a show at the Museum of Modern Art. There's actually a version of this up running right now in a show called Pirouettes. So if you want to see what these times happen to be in New York, it's fun as well. So, but again, this is, it was helpful to kind of do that exercise to kind of get a sense of, yeah, it's bigger than you think. And then also be able to do, let's see here, looking at stuff like this, where this is the darkest part is the coding area. This is the non-coding area. This middle purple is the intron. So basically in between the coding sequences, there's sort of semi-coding things, or important, structurally important, but non-coding kind of things happening. And so just design-wise, that gives you a sense of what the balance of your data looks like. And so, again, just how do you quickly get those pictures in place? This was part of the thing behind the rowboat stuff. That it's just like, I don't. Well, we just did a thing. I'm teaching this semester an information design class. We just did around with the students, kind of give them data sets and that, have them kind of go find things and then kind of present that back what they found. And then from there you can say, oh, do I want to do something more sophisticated or whatever? But I think just that idea of how do you quickly start making sense of it, and because the end problem is not necessarily, that it's not about like, hey, I need all 50 million letters. It's, oh, that 1 million coding letters, or that 50,000, or how do you, you're just looking for ways to kind of find the right things and sort of bring those forward.
Well, I'm curious about the designs that you have and the process of selection of designs.
Sure. Basically,
the conversation that you have with designers between their needs and what you want to bring on the table. How does it look like?
Let's see. Yeah, I mean, it's or is there a specific part of that seems like a friction, or just curious?
Yeah, I was curious about what are the kind of clients you work with?
Yeah. So
do they come to you, or maybe do you go to them?
Yep. So we've been really lucky that folks are typically coming to us and finding us, or being referred by others, things like that. We as a group like to focus on people who are domain experts in particular. So just we like these sort of gnarly, what's actually happening here kind of problems, and also kind of back to the example of kind of the design school thing of hey, I want to work with clients who are in an interesting domain, and so then I get to learn all about it. So like we've learned a ton of stuff about infectious disease and now phylogenetic trees, and Miles Davis and Ron Carter, playing bass all over the world, and so so we that part of it is really interesting and critical for us, and then also trying to find folks who want to are interested in kind of help with thinking through a problem. So like we'll occasionally get inquiries that are kind of like, well, we have this data set, we need a map, and it's going to be interactive, and it's like, cool, somebody can build that for you, and we kind of try and stay away from those types of things, because if they one, it's probably not a map, it's probably not, they may be wrong, as we find with kind of digging into different data sets, but also that's especially now, it's a very commodified sort of thing. You can build that, you can hire somebody to kind of make those things happen. And so as much as possible, we want to have folks who are excited about, hey, like what I like when they have a version of what they've been trying to do and they're and like we can kind of say, oh, here's where we can, here's where we can go next, or we can see what you're trying to do with this and what's breaking down. Sometimes it's, hey, we have these different things in existence, and we need to know, like, kind of show the version of what this should be like in 5 or 10 years. And so we're going to have you work on a separate track from our internal team who's very capable, but we need you to, kind of build the thing that's going to be kind of push them along further and kind of, isn't tainted by internally kind of their day-to-day schedule.
Thanks, Ed. Very, very interesting talk. I don't think I can leave without asking that question. Well, there are 2 questions. Like, the first one is more technical.
Premeditated.
It's like, how can you make like things like robot like so fast? Which kind of like technology you use?
Yeah.
Quite interesting.
Yeah.
The other one is how do you think about the future and like new things like AI, and how do you think that affects your work, and how do you think about that strategically?
Yeah. So the rowboat thing, so basically what's underneath that is we wrote an engine in C++, C and C++, just really heavily tuned based on just years of, okay, how do we munch through data quickly and things like that. Using WebAssembly to compile that for the web, and then we can kind of run that in a browser. We lose about half the speed by doing that, so it's even faster when we run it locally. But what we found is that of all the things that people responded to for what it could do, the speed they were fine with. And it's like, oh, but it can be twice as fast. It's like, we're good. It opened this thing in half a second, and it takes Excel 25 or a minute 25. And so like just kind of that's that sort of bespoke custom. I don't ever want to have to go into the CSV parser that is underneath that. And so just kind of taking a bunch of experience and kind of dumping into that. So that was the performance one. And then as far as the future, I am terrible at predicting the future. I like the whole like, oh, if you build the future, you're better off like than trying to predict it. But that means you have to build the future then stuff. The AI stuff, I'm not nuts about the AI stuff. And as a studio, we've been staying out of it. That's a whole, at some point I need to kind of sit down and like kind of write all that out. I keep thinking, but it's like,
we have thought about it.
Yeah. At some point I need to like kind of write this down, but it's kind of like, hey, it's like information design wise, it's like, information design, it's all about like, I've got this black box and I'm trying to understand this data set. It's like, now I've added AI to it. I've got 2 black boxes, so I need to understand what the AI is doing. And, so but it's a tool, and like any other, there are going to be things that are useful about it and whatever. I am not particularly interested in being the anti-AI, whatever, sort of person. So I haven't pursued that part of it, but generally speaking, I mean, like, what is it, the Miyazaki thing that's been kind of making the rounds this week, like the director of Miyazaki, who does all the Studio Ghibli work, calls it an insult to humanity. I'm kind of like with that as far as like just the process of creation and kind of the things that it is not writing, it is not image generation, like it just all the things I love about his work versus the things that are generated by this stuff. So, but yeah, as a company, it is not a popular opinion. It's not a way to get rowboat funded with VCs or something like that. If we said, hey, here's rowboat with AI, I think we have all the funding options. But also even with rowboat, it's kind of antithetical, that it's like the thing we're trying to do is how do you do ridiculously fast and accurate answers? And AI is slow at giving you approximations of things that might be completely made up, and so we, because I was talking to different funders, supporters, et cetera, about Rowboat. And so we actually did a little detour for a couple of weeks and internally just kind of, okay, what would this look like? So how do is there a way we can use the AI stuff to kind of make this more accessible and whatever? And that we found that it just kind of, I don't know, that's a whole other, some of the things we found are interesting, some less so, but it was interesting. My crew, the more allergic reaction they had to it, that they were not super comfortable kind of working with. Which I try and be, pragmatic about this stuff. And it's like, that's fine.
I have a use for, so if I have a archive of text, like articles, can I use Robot for that?
Yes, a bit. So we just added.
We just add.
Finish your thesis first.
Yeah. We just added some stuff around even just doing basic text analysis work. So here's a breakdown of Taylor Swift lyrics.
Is this example on the website?
Yep. So, or actually, this one may not be, but I think it's a Kaggle data set. And so in the lyric column, we have, here's all the lyrics, 4,862 rows of Taylor Swift goodness. And we can just do some basic text analysis stuff with this. So a lot of so gets us some basic things about what's happening in the text, but nothing is more involved with as like other things we've done, like our on-care project, which is more of like doing topic modeling on really large data sets. So this is a massive collection of 38,000 articles from Wikipedia, and just how do you kind of navigate that and find different topics inside of it. So we'll keep adding stuff here and there, and hopefully we can get to this kind of thing.
We're going to wrap up here.
Awesome, thank you.
Thank you so much.